So 6.2, example 6. I don't remember what that was supposed to be, so we'll just ignore it. And we have enough examples, so we're just going to ignore this one. I'm just going to wipe this out so it doesn't distract us. We're just going to ignore it. I don't remember what it was. We do so many examples, I think we're good. So I'm going to take that off. Okay. Determine the following. I want you to determine cos theta for the angle with the terminal arm passing through here. So again, I'm going to draw it. Terminal arm passing through this, and I want to find cos theta. So this is cos theta equals, that's what I'm looking for. I'm going to draw it over here. Make sure your diagrams aren't too small so you can read your own writing. Right? So when you're drawing, especially on rough paper, make sure you can read it. So it's positive 5 along the x, so 5, and then negative. So it's somewhere down here. So drop it, oops, right here. Drop it at right angles towards the x-axis. Always at right angles. It's like a bow tie. It always hits right angles. So it's going to be a perfect bow like that. So always right angles here. Never anywhere else. Never, ever, ever. Right? And so I know that this is positive 5 along the x, and this is negative 5 root 3, right? The negative, because it's heading down. This is my little acute angle beta b there, right? So it's always between the terminal arm and the x-axis. I want you to find cos theta. Cos theta is the cos of that whole angle, knowing that we're taking the negative into account. That's what makes it the theta, right? So we're good for that. So we've got the negative there. And I want adjacent over, so we're just using SOHCAHTOA. So this is just a straight SOHCAHTOA question. I need adjacent over hypotenuse, but I don't have hypotenuse. So this question is to remind you of how to fill in some of the diagram if you're missing part of it. So we're going to do Pythagorean theorem. You don't have to name it. Okay, you don't have to name it, but that's what we're going to use to find this missing side. So I'm going to call that R for the radius. And we're doing square root of 5 squared plus negative 5 root 3 squared. Right, we're adding it to find the longer side. We're going to keep going. That's 25 plus, what's that squared? 75. 5 times 5 is 25 times 3, yes. And if you can go faster, go right to 75. Okay, just wanted to remind you of that. And then it's 100, which, yes, you can go faster, so then this would be 10. Okay, so if you can do that part faster, go ahead and do that faster. Okay, but you need to be able to use Pythagorean theorem. The main thing for this one is, yeah, Pythagorean theorem, so that you find the missing side here. Okay, so if your side is missing, and if you're finding the shorter side, you're using minus, right? So again, Pythagorean theorem. So all we're doing is taking this, and we're going to go 5 over 10, which is 1/2. Right? So it's an easy question. I was just reminding you of Pythagorean theorem. And another one. Terminal arm in standard position passing through the point. It's getting repetitive, so hopefully you're like, you do too many examples, you worry too much. So I'm just doing another one. Just make sure you can read through and see what I'm asking and what we're given. So we have a terminal arm of an angle in standard position, which again means it's at the origin, facing out, passing through the point 7,5. I'm just going to go ahead and draw it. I feel like drawing it. Unfortunately, I gave you the same quadrant. Aren't I silly? I have to change this example. 7, negative 5. So drop it. That's 7. No, that's negative 5. I got to change this. I have the same quadrant again. That's boring. Find the radian value. Okay, radian. It already tells me the interval. So that's the interval notation between 0 to 2 pi. So that already tells me radian. So me saying radian value is already redundant because I already have that. Of the angle to the nearest hundredth. Okay, so 2 decimal places. I'll keep 3. And we want, again, this is already covered with the negative, and it's terminal arm, fine. Oh, what am I looking for? I'm looking for theta, not the ratio. So see how the question changed a little? So the one above, I said find cos theta, find the ratio. This one is almost the same question, but I'm asking you to find the angle this time. Okay, so see how it just varies a little. All the information is the same though, almost, right? We've got all the stuff here. So I know this is my little angle beta b there. I'm going to go ahead and find my angle beta, and then I'm going to find the full angle by doing, I'll find the full angle by doing 2 pi minus that beta, whatever it is, right? But I got to find the beta first. How do you suggest I find the beta? So in my head, I'm thinking find beta. Doesn't tell me to do that, so that's why it's a plan of action. I'm going to find the beta. How can I find the beta? Thoughts? Yeah.
Trig ratio.
Trig ratio. We have a 7 and a negative 5. What trig ratio would be better to use?
10.
10. You could use any of the others, but then you have to find this by using Pythagorean theorem, which we know how, but also you're wasting your time. So the best strategy is use 10, right? So we already have opposite and adjacent, right? So might as well use that. Again, you can do this. It's just more places where you can go wrong, and then you're wasting your time. So if you're doing every question kind of the slowest way possible, it's going to catch up to you, right? So I have opposite, I have adjacent. So I'm going to go tan beta equals negative. Oh, do I need negative? Nope. So 5 over 7. And remember, I always do the positive ratio for my little beta. Okay, so then beta, do you need to show me this step? No. Okay, you can skip this step and go straight to here. On your calculator, I just want to point out, I think that it comes out wrong if you don't put the bracket though. So I'm on radians, always check. Do I want radians? Yes. Are you on radians? Check. Okay, check every time. You'll notice because the degrees are much bigger anyway, right? So shift 10. And then I think this calculator needs a bracket, 5 divided by 7. Some calculators don't, but I think this one does. Otherwise, it only does the 5, and it doesn't know what to do with 7. So put bracket, 5 divided by 7 equals, and I got that. I'm going to keep 3 decimal places, even though I only need 2. So 0.620 radians. Okay? And then I'm going to find my answer. So theta equals 2 pi minus 0.620 radians, which gets me approximately 5.66 radians. Right, so it's almost the same question, but I was asking the angle, not just the ratio. Okay. Last question. For example 8, these ones here are special angles. So these are all just random radians and radians. So for example 8, they're all special angles. Anytime I see 0, 1s, and negative 1s, I want you to use, so anytime I see 0, 1s, and negative 1s, and I taught you guys learned this in grade 11. I know it's been a little while. So 0, 1s, and negative 1s. So I would tell my students, I'm going to do this. Anytime I see 0, 1, and negative 1, I want you to go to this. I said this was the easiest way to do it. Okay. This is the best way to figure out your 0, 1s, and negative 1s. And we do this last year. Again, you can do it other ways. Some people memorize, look, what did we do over here? These guys here, 0, 1s, and negative 1s. You memorize it on the chart, on the unit circle, so 1, 0, 1, 0, and then you do it this way. That's fine. So if you can do it this way pretty fast, that's good. Some people go, you know what, I hate going backwards from this because then you have to go backwards from it to figure out which angle it is. So I recommended this. Okay, so again, both ways are wonderful. Just I find this one's a little bit more visual, so some people like it a bit better. So anytime I ask you 0, 1s, and negative 1s, you go here. Which graph is this one? Sine, you know that, right? And this one, cosine. Now, what's different this year compared to last year is that we did this in degrees. What is this one going to be? Not in degrees, but in radians. This will be 2 pi. We're actually going to graph in 6.4. So in 2 sections, no, 6.3 tomorrow. So we'll do the graphs tomorrow. I like the graph, so even though they didn't teach you the graph, this is 2 pi. Does that make sense? Instead of 360 here, this would be pi. Good? Okay, how about here? How about one here? What's 90 degrees? Pi over 2. How about 270? Half, 1 whole, 1.5. How do you do 1.5, 2? Remember, it's half, whole, 1.5, 2. You're doing slices. What's 1.5 in fractions? 3 pi over 2. Is that okay? So one more time. What's this last number? 2 pi. What's the halfway? Pi. Half of that, pi over 2. We're getting prepped for tomorrow's lesson, or the 6.3 lesson, not tomorrow's. This one here, what would this one be? Half, 1, 1.5. 3 pi over 2. Does that make sense? Okay, so we're going to use this idea. Good? For 0, 1s, and negative 1s. Now, you might be going, but wait, those two aren't 0, 1s, and negative 1s. Do you recognize that this is the same thing as 1 over root 2, but it's been rationalized? You should. You should be like, okay, I think I see that one. How about this one? Do you recognize that that's the hypotenuse 2 and the opposite or adjacent root 3? So you're supposed to recognize that these are also special angles. So these are special angles, even though they're not one of the typical ones that we did, right? So it's not 90, 60 stuff, but those are special angles. I'm going to show you a trick. So sometimes you're like, I wonder if that's special. I'll show you a trick on the calculator we can do for that. Now, let's read the question. What is the question asking? The question is asking for us to, for each of the following values of sine theta, determine the radian value of theta, so determine theta, between pi over 2 and 3 pi over 2. So now this is worded differently as well. So slightly different wording on all of this question. So pi over 2 is how much again? 90. And 3 pi over 2 is? See? 270. So they want you to use quadrant 2 and 3. So 2 and 3. So they want your answer to be in quadrant 2 and 3. That's what this is saying. This is saying quadrant 2, 3. Right? So just a fancy way of asking it. Right? Isn't that fun? Right? So instead of asking you the regular way, they went, oh, I'm not saying quadrant 2, 3, but I told you in radians. So same thing as me saying between quadrant 2 to 3. From here to here. Okay. I want you to understand what this is saying. This is saying these are sine theta. So this is actually, the way they worded this question, again, the reason why we pulled this one to do with you is because they're actually giving you, so write it on the left side. Sorry, I didn't leave you enough room. So right on the left side. They're saying sine theta is negative root 2 over 2. That's what they're saying. For each of the following values of sine theta, they're saying that sine theta is that value. They just didn't write it the same way. So it's actually the same question as the other one where they said tan theta equals cos theta equals, but they worded it instead of writing it. That throws people off. They're like, what did you give me? They gave you, it's the same as this. See, tan theta is this. They didn't write, they said it in words. The value of sine theta is this. So it's the same. So you can set it up. So go ahead and set it up. Okay, so sine theta is this. Now you can try to answer the question. Now, it's a special angle. Now, that special angle, we can't use this. This is only for 0, 1s, and negative 1s, right? So here, you're supposed to recognize that this is the same thing as negative 1 over root 2. So I would unrationalize it. Go, okay, I know that's 1 over root 2. So what angle would that be? If it's opposite over hypotenuse, what angle is that? 45. 45, but it's a negative. So we know that for beta, it's going to be 45 degrees, right? So you can go, oh, shoot, I did it in degrees. I want it in radians. Can you convert that to radians for me? What's 45 in radians? Pi over 4. Want me to show you a little cheat? On your calculator is not useful in radians to go exact. So look, watch what happens. If I did the beta, so shift, sine, bracket, and I did without the negative, root 2 divided by 2. Ugh, that's not exact. That's radians, right? So that is pi over 4 divided by, I'm not memorizing that. But look, I'm going to switch it to degrees. Watch what happens when I do it in degrees. Shift, bracket, root 2 divided by 2. I got 45 exactly. So if you're pretty sure it's an exact, a special angle, you can switch the mode to degrees, go, oh yeah, I was right, it's 45. So if you look at it and go, I'm not sure if I'm going to remember 1 over root 2. So check it. Check it. And you can check it as root 2 over 2 and go, oh, it is 45. I was right. I'm a genius. And there you go. Right? So same with this one. If you look at it and go, oh, I'm not sure. You should stop, though, and go, okay, I think that hypotenuse is 2 root, that root 3s, root 2s, that should make sense. What's this one going to be? So if I tell you sine theta equals root 3 over 2, and I wanted just to do the beta, please. So let's do the beta. Right? So the beta would be, so plug that in degrees. What do I get? It's root 3 divided by 2.
6.
Yeah. So if that helps you, go into degree mode and then flip it over. If you can see it, even better. You're supposed to see that the opposite is root 3 and the adjacent and the hypotenuse is 2. Some people go, I don't know if I'll see that. Like, I think that I'm going to forget. So watch out when you're doing these ones. When you see that one, you should hopefully see it 60, but it's pi over 3. Okay? And if you can't, you can check it in degree. That's what I'm saying. You've got to be able to go back and forth in the modes. Okay? It's not going to work if I say 1 over 7. 1 over 7 is for sure. You have to be able to recognize it like that and go, 1 over 7 is not special. Root 3s are special, 2, right? Root 2s, right? You should, if you're checking every single one, yes, you're not going to be able to finish a test because you're going to be like, I'm doing it in the worst way possible. You're checking everything. But when you stop and go, oh, I'm pretty sure that's an exact one, I can go 60. If you're checking, so do I need to check 7 over 24 to see if it's exact? It is not exact, right? So if you're checking every one, it's not going to help you. You're never going to finish, right? But if you're checking the ones where you're like, oh, I think that's special, then you can do that, okay? Did I answer it yet? No. What's theta? I didn't even answer the question yet. So here, I know it's pi over 4, but I want it in quadrant 2, 3. So can you please flip it so it's in quadrant 2, 3? So C-A-S-T, and I only want it here. So can I do it in both S and T for sine being negative? Sine is, no, only here. So I actually only want one answer. So therefore, theta equals, how do I get all the way over here? 4 over 4 plus another quarter, 5 pi over 4. Right? So that's why I need you to be able to picture the slices. Because you got to be able to, if you're, otherwise. Oh, and the other way you can do it is pi plus. So this will be pi plus pi over 4. Right? Or you can just do 5 pi over 4. I'm hoping you see the slices a bit better so that you can do it faster. Okay, it's not about speed, but kind of like comfortable. Right, so pi plus pi over 4, is that all right? And then that's 5 pi over 4. Okay, 1. Are we good with the chart? So I'm going to put the chart over here. I wrote it bigger here just because it was too squishy. So for 1, sine, oh, I'm going to rewrite it. I hate this question. I actually, because they put the ratio here and the 1 here, I feel like I don't know what I'm calculating. So I go sine theta equals 1. So when is sine theta going to equal 1? When does sine theta equal 1? So go here. It only equals it at pi over 2. Is that okay? Is that in the domain? Yes? Yes. Okay. This one here, sine theta equals 0. What do I get? So I know theta equals 0, pi, and 2 pi, right? 0, 0, 0, but I can't use all of them. So therefore, theta equals, so this one, I'm going to take off which one? Domain? This one? Because of the domain. So pi and 2, oh wait, no, can I do 2 pi? I can't. It's also out of the domain. Oh, sorry. So I'm going to take off here. So domain, and so pi only? Is that okay? Thank you. Stop me if I'm wrong. And then one last one. Where is it? -1. I only did sine this time, so I only need this one. So that would be 3 pi over 2. So just 3 pi over 2, right? And it's in the domain? It is, because the domain goes through. Done. All right. No questions? We're good.